Bismillahirrahmanirrahim. Welcome to MIT. Today we are going to solve a problem which belongs to kinematics, and this may be the second video on kinematics. And the question I have chosen from paper 9709/41, that means it's an A level question paper. So the paper variant is 41. Let's see what the question is. The question says a particle moves in a straight line starting from a point O. The velocity of the particle at time t second after leaving O is v meter per second. It is given that v is equal to kt raised to half minus 2t minus 8, where k is a positive constant. The maximum velocity of the particle is 4.5 meter per second. Question number A says show that k is equal to 10. So what is the concept we are going to apply here? Actually, when the clue word of this question is maximum velocity. At the case of maximum velocity, acceleration is 0. That means we will apply the concept of acceleration equal to 0. And we know acceleration is the derivative of velocity. So let's find the derivative of velocity. dv over dt will be 0. So this is the concept we are going to apply here. And derivative of d over dt of what? Our velocity is, the function is kt square minus 2t minus 8 equal 0. And we are going to find the derivative of this function. So 2k, sorry, it's not 2, it's half actually, t raised to half. So it is going to be k and half, that means 2 will go down. And what will happen to this function, I mean t is going to be, if we subtract 1 from half, it is going to be negative half. So negative half means that is actually denominator. Okay, 2 raised to half. Let me write this again. Before that, I'm going to erase this because the lines are very close to each other. Let's have some more space. Well, so it is going to be equal to, well, our half is going to be multiplied by the coefficient is k. If we multiply by half, it is 2. And what will happen to this t? T is going to be, look, half minus 1. Okay, if we simplify this, it is going to be actually negative half. Well, so the degree of t is now negative half. So negative half means actually it is denominator. And minus, let me erase this part, 2 because derivative of 2t is 2 and derivative of 8 is 0. So right side is 0. That means we are going to get k 2 square root over t equal to 2, or k over root over t is equal to 2 to the 4, and actually our square root over t is equal to k over 4, and we are searching for actually t. So t square is equal to k square over 4 square means 16. So this may be left as equation number 1. Equation number 1. Well, because if we go back to the question, we will see that there are actually two values missing, neither k nor t, both of them are missing. So if we want to find both of the values simultaneously, then we will have to undergo the simultaneous equation. So one equation has been formed, another equation, and for this equation we have applied the concept of maximum velocity is equal to 0. That means acceleration is equal to 0, which we can call in another way derivative of velocity is 0. So one concept has been applied, that maximum and minimum concept of velocity, that means acceleration is equal to 0. And second concept is actually the maximum velocity of the particle is given also, the maximum velocity. So one of the velocity is given, we can apply this one as well. So let me draw a line just beside this. Let me see whether below this there are space or not. No, we don't have space. Then I will have to write just beside this. Let me draw a line over here. So our maximum velocity is given how much? 4.5. It is written 4.5. So let's write maximum velocity. V is equal to 4.5. 4.5. And our V was, what was our V? Our V was k root over t, that means k t raised to half, which can be written as square root. If the exponent is half, that is actually square root of t, minus 2t minus 8 is equal to 4.5. I can show you again. Look, the question was here k t raised to half minus 2t minus 8. That means k raised to k square root over t minus 2t minus 8 is equal to 4.5. Now, if we simplify, we are going to get k square root to, we can standardize this first of all. Let's do the standardization, because power of t, exponent of t is greater here. So if we standardize, it is going to be negative 2 plus k raised to half minus 8 and minus 4.5, it is going to be actually 12.5 equal to 0. Or if we divide everybody by 2, no, we cannot divide by 2, but at least the symbol can be simplified. So it is going to be 2t minus k square root over t minus 12.5 is equal to 0. Now we can substitute the value of t from equation number 1. Let's see how much was t. T is here k square over, this is the value of t. T is equal to k square over 16. So let's substitute this value. That means it is going to be 2 into k square over 16, then minus k into square root over k square over k squared over 16 minus 12.5 equals 0. So what is it going to be? It is going to be actually 2k squared over 16, and the second one, square and square root will cancel each other, so it is going to be k square, k into k square, and square root of 16 is actually 4, minus 12.5 is equal to 0. Then we can simplify more. It is going to be, or LCM is 16, or we can multiply everyone by 16. Let's multiply everyone by 16. So it is going to be 2k square minus 4k square minus, if we multiply by 16, it is going to be 16 12s are 192, so 200. It is going to be 200 equal to 0. I'm extremely sorry, I made a mistake over here. Look, if the symbols are interchanged, then this should be positive. So it will also be positive. This one is positive. That is in front of 12.5, there will be positive symbol. That means this is also positive. Okay, then if we simplify here, it is going to be negative 2k square plus 200, well, equal to 0. Then what are we going to get? If we simplify it, 2k square is equal to 200. From both sides we are avoiding or omitting the negative symbol. That means k square is equal to 200 over, that means 200, if 200 is divided by 2, it is going to be 100. Okay, and hence our k is equal to square root over 100 means 10, And in the question we can see that the question told that k is positive. Look here, it's written k is a positive constant, so we can ignore the negative value of k. It cannot be negative symbol over here, it's only for positive value. So we have shown that k is equal to 10, and we can write the notation shown or showed. Okay, so what is the concept we have applied here? For solving this question, there are two concepts. Actually, one concept of physics concept has been applied here. That one is whenever velocity is maximum, then acceleration is zero. And we know acceleration is the derivative of velocity. That's why we have written over here that velocity is equal to zero. Velocity is velocity of the particle is zero. So this is the very crucial concept to be memorized, that whenever maximum or minimum velocity mentioned, that means acceleration or derivative will be zero. And as there are two, you know, variables missing, or one constant another variable, t as well as k, t is missing, k is missing, both of them are to be obtained. And applying only one equation or one concept, we cannot find both of them. That's why we have formed two simultaneous equation, or one simultaneous one equation, and that obtained value has been applied in the second case. So there will be two cases for finding two unknown variables. Well, I think you have understood this. Well, let's move on to the next question. Our next question is, let me see what the next question say. The next question is, it says verify that v equal to 0 when t is equal to 1 and t is equal to 16. That means the particle comes back to o or 0 when v is, t is equal to 1 at 1 second and 16 second, velocity is 0. So let's write velocity. Velocity was, we have got our v is, let's see what is v. V was that kt raised to half minus 2t. So it's actually what v is equal to k, we have got t 10, and t raised to, that means square root of 10 t minus 2t minus 8. That means this is our velocity function. Now v equal to 10 square root over t minus 2t minus 8. Let it be written there, 10 square root over t minus 2t minus 8 is equal to 0. Then we can standardize this. This is actually 2t, because t is having maximum exponent 2t plus 10 root over t minus 8 is equal to 0. If we simplify, if we divide everybody by 2, it is going to be negative 2. Then it is going to be t minus 5 square root over t plus 4 to the 8 equal to 0. Or we can now we can factorize this. If we factorize, it is going to be square root over t square. T can be written as square root over t square. Well, for converting into quadratic equation, minus, we can write here 4 square root over t minus 1 square root over t plus 4. This is simple factorizing. I think all of you know how to factor, how to factorize any quadratic equation. Let me write just below this. It is going to be, so from in the first pair we can take square root over t as common. If we take square root over t as common, it is going to be square root over t, one of the factor, and the other one is going to be square root over t minus 1. Here between these two, one is common, equal to 0. So either square root over t is equal to 4. Square root over t equal to 4 means if we square both sides, then it is going to, t is going to be 16. This is the first value, or this can be supposed to be the second value. First one maybe this is the second value. Okay, or or square root of t is equal to 1, this factor. Okay, hence our t, if we square both sides, is it is going to be 1. So we have shown that our values are, hence t is equal to 1 and 16 when velocity is 0. We have shown the statement. Well, now we are going to solve the immediate next one. Let's see what the immediate next question say. Immediate question is actually this, the second part of this question. This says find the distance traveled by the particle in the first 16 seconds. So it's very crucial, and the if concept is not very clear in this case, it will be very difficult to solve this. And we know the first concept we are going to apply. Before that, let me erase this. One concept is very well known to all of us, that for finding distance we will integrate the velocity function. So this is a very common, and we are surely going to apply the integration of velocity function. So velocity function is actually v is equal to, as per I remember, negative 2t plus 10 square root over t minus 8. But the question is actually, if we find this is, look, a definite integration from first seconds 0 to 16. Okay, so if we randomly do this, then we are surely going to make a mistake. Let me show you how. Our velocity graph is v is equal to what? V is equal to, we have factorized in the previous case, v is equal to negative 2t plus 10 square root t minus 8. Okay, now as you have we have already factorized, the roots were what? 1 and 16. So this, that is actually t minus 1 as well as t minus 16. Okay, if we factorize this, so we have got this way. Now the question is, what is the problem if we integrate velocity directly from, you know finding the limits from 1 to 16? Let me show you the graph. The graph of this one is going to be, suppose here it's o, here t seconds, and our roots are 1 and 16. Suppose here there is 16, and y-intercept is, here negative 8. So this, suppose this is negative 8. Okay, negative 8. Well, so graph will look like, as this is negative function, so graph will look like this. Okay, from here it will come this way. So, what is the problem we will face if we directly find the integration or find the distance? Then look, this portion of the, let me change the ink. This portion lies below the x-axis, whereas this portion lies above x-axis. So, if you find the distance starting from here to here until the last 16 seconds up to this, then it will be a great mistake, because this portion, the portion lying under the x-axis, will produce negative value. That's why actually we will have to find the distance part by part. First we'll find this portion. Okay, so for this portion we will find the integration of velocity function. So let's start. Our v is equal to negative 2t minus, sorry, plus 10 square root over t minus 8. Well, so we are going to integrate this. Integral of v dt is going to be, if we integrate this, it is going to be, power is 1, so it will be now 2, increased exponent is 2, so negative 2 over 2, then t will be square plus here the exponent is half. So if half is added to 1, half plus 1 equal to actually 3 over 2, and this derivative will go downward, 10 over 3 over 2, and t, the power will increase to t raised to 3 over 2, and the integrand of 8 is 8t, actually 8t, and plus constant number. Okay, and we have already known that integral of velocity is actually acceleration, so we can write, sorry, not acceleration, it's distance. So distance can be termed as s1. Okay, s is equal to, and if we simplify this, it is going to be negative t square plus, it is 10, then 20, it will be reciprocal 20 over 3, then t raised to, let me write this portion a little bit lower, let me erase this part first. So s equal to, or s is equal to, this is going to be negative t square, and it is, if 2 multiplies 10, it is going to be 20 over 3 t raised to 3 over 2, 3 over 2 minus 3 over 2 minus 8t plus c. Actually c is the constant number. Here there is no constant digit, we can avoid this, because look at it, look at this, when t is 0, our distance is also 0, it starts from origin, or you can leave over here. Whenever we convert it into definite integration, then we can avoid that one. Okay, now what we have learned, that directly from 0 second to 16 second we cannot find. Why? Look at this, I have already explained that for this lower portion, this portion will show negative value. So first of all, what will we do? Our limit will be from 0 to 1. Here is 0, 0 to 0 until 1. We'll find the distance covered during this time, 0 to 1 second. So s1, we will write s1. Let me find some space to write. The first phase is s1. Okay, s1 is equal to, what was our integrand? Our integrand was, look, s1 negative t square plus negative t square, t square, and our limit, we have already fixed our limit, was from 0 to 1, 0 to 1, negative t square, then minus, what was the next one? It was minus 20 over 3 t raised to minus 20 over, minus 20 over 3 raised to t raised to 3 over 2, 3 over 2, and our limit is 0 until 1, and minus 8t, our limit is 0 until 1, 0 until 1. Well, then what is it going to be? It is negative and 1 square, so 1 square minus 0, then 20 over 3, again 1, actually 1, whatever the exponent is, 1, 1 minus 0, then again 1 minus 0, 1 minus 0. Well, so it is going to be negative 1, negative 20 over 3, then negative 8. Is all of them negative? No, everyone is not negative. This is actually positive in the integration. So if we find this, it is going to be 3, negative 3 plus 20 minus 24. Well, means it is going to be negative of, equal to 3, so 27, negative 7. Okay, and that's why I have told at the beginning that the lower part of the function or graph will, this part has shown negative value, but we are finding for distance. Distance can never be negative. That's why we will use modulus symbol. Let us use modulus symbol. Then we will get the we will figure out the positive value, this one. So we will use modulus symbol over here, this, as well as this, and then over here also modulus symbol for getting the positive value. So ultimately the distance covered in the first 10 seconds is equal to from first 1 second was equal to 7 over 3 meter. Okay, we have completed finding the distance traveled in the first phase. Let's talk about the next phase. For the next phase, the time was, let us see what was the next phase. For the next phase, time was, it was 1 second and it was 16 seconds. So time from 1 to 1 until 16 seconds. So thus we have already integrated. Our integrated function is this one. Integration has been, remember we didn't use this c because for definite article there is no constant number, so c is unnecessary to be written here. And this is actually our the distance function. Okay, the integrated part of velocity. So let it for the second phase, it's from 1 to 16. Okay, let me find out some space to write. We can write it as s2. Okay, s2 is equal to, our limit was, what was our function? Our function was negative 2. Let us see what was it. It was negative t square. Okay, negative t square plus, so negative t square, and our limit is from 1 to 1 until 16 seconds, plus 20 over 3, 20 over 3, then t raised to 3 over 2, then minus minus 8t, 8t, 1 until 16, 1 until 16, time is 1 until 16. So it is going to be 16. This is actually square, sorry, here there should be an square, it was a square. So 16 square, it is minus 16 square minus 1 square. Okay, then plus 20, same goes for this one, 20. Let me write this on a new page actually. Well, this is our expression. So what will we do? Negative, then t is 16, so 16 square minus 1 square, then plus 20 over 3, that is 16 raised to 3 over 2, minus 1 raised to 3 over 2, minus 18 to 16 minus 1. Well, then 16 square means 256 minus 1, so minus 255. And in the second one, 20, sorry, plus 20 over 3, and 16 raised to that, that is actually 4 cube. 4 cube means 64. So 64 minus 1 raised to something is 1, minus 8, 16 minus 1 is 15. So 8 15s are 120. So one more step, we can write 255 plus, this is going to be 63. 64 minus 163. If 63 is dissolved by 3, it is going to be 21. So 21 into 20, that is going to be 420. 420 minus 120. So from 420, if we subtract, then if we subtract 120 from 420, it's 300. 300 minus 255, it's 45. So for the upper part, we have got 45 meter. So this is the second phase. And in the first case, we got the velocity as the distance. In the first one, it was, this is second part. So in the first part, we have got how much was our distance. The distance was this, 7 over 3. So we are going to find the total distance. Total distance is hence total distance, let me write a little bit up. Total distance. First there was 7 over 3, now 45 meter is equal to, if we calculate, it is going to be 142 over 3. If we round it up to three significant figures or one decimal point, it is going to be 47.3 meter. So this is the answer we are asking for. So total, ultimately our final distance traveled is 47.3 meter. So what is the concept we have learned from this? The first case, directly we cannot find, they have told us to find the distance, and we know if the velocity is given, then easily we can find the distance by integrating the function. But here the problem will arise if we start finding the distance directly from 0 to 16. It will be a mistake because some parts of the graph is lying below the x-axis. So always the part below the x-axis will produce negative result, but we are actually seeking for positive result. That's why we will have to use modulus symbol for finding the area below the x-axis. Then for the second phase, so it is sure that we will have to find the distance in two phases. First from 0 to 1 second, then from 1 to 16 seconds. And you know the well-known concept for finding distance using velocity is the integration. I think you have understood whatever I have explained, and I tried my level best to make you understand. So thank you all for being patient with me and for learning whatever I have explained. Thank you all.